Base launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
You are looking at a live view of Falcon 9 and Dragon awaiting liftoff from Launch Complex 39A at NASA's Kennedy Space Center in Florida. In just over 18 minutes, Falcon 9 will lift off carrying Dragon and the CRS-31 mission to the International Space Station. Good evening, I'm Yomei Zhou, a lead propulsion engineer here at SpaceX. Dragon will deliver about 3 tons of science, supplies, and equipment to the space station and will return with over 4,000 pounds in about a month. After an almost 13-hour flight, Dragon will autonomously dock to the space station on Tuesday, November 5th at approximately 10:15 a.m. Eastern Time. This mission will mark SpaceX's 105th flight of 2024 and Dragon's 5th trip to the station this year. Today's spacecraft will be the first Dragon supporting a cargo mission to fly for the 5th time, and coincidentally, the Falcon 9 booster supporting today's mission will also be making its 5th flight. Reusability is key to everything we do here at SpaceX, and to date, we've reflown Dragon spacecraft on 27 missions and Falcon boosters on 333 missions combined. Dragon is the only U.S. vehicle flying today that can fly round-trip to and from the space station, carrying vital supplies and returning safely with critical cargo. The spacecraft flying today may also be the first Dragon to perform initial tests once docked with the station that demonstrate Dragon's reboost capability. These tests are designed to show Dragon's ability to control the station's attitude and altitude, with more on that in just a few minutes. Now, over at the pad, propellant loading began about 15 minutes ago and will complete at the T-minus 2-minute mark. Weather is looking great with only a 30% probability of violating launch weather constraints. The eastern range is green and ready to support, and everything is looking good as we count down to an instantaneous launch attempt at 9:29 p.m. Eastern Time today. With that, let's check in with Joseph at NASA in Houston.
I'm coming to you live from the International Space Station, a flight control room at NASA's Johnson Space Center in Houston, Texas, where our flight controllers, led by Flight Director Ron Spencer and his Gemini flight team, are monitoring the International Space Station, Dragon's ultimate destination after tonight's launch. We're closely following the launch and collaborating with you and the teams in Hawthorne, as well as the Falcon 9 team at NASA's Kennedy Space Center in Florida, to ensure that all launch criteria are met. Now, earlier in the countdown, a device called the Lab Router that enables telemetry for the crew on board the International Space Station to monitor Dragon went down. The crew was then briefly awakened from their sleep shift and recycled that router successfully. And right now, I am happy to report that the teams here in Mission Control are go for launch. The International Space Station and its crew members, including NASA astronaut and Commander Sonny Williams, Butch Wilmore, Don Pettit, and Nick Hague, are ready to welcome Dragon with its anticipated docking tomorrow morning. The crew is rested and ready to receive Dragon after witnessing the relocation of Crew 9's Dragon spacecraft after relocating from the forward-facing port of the station's Harmony module, Node 2, or the zenith-facing port of the module to clear its path for the arrival of the commercial resupply mission. Now, as we shift our focus here in Houston to the countdown for Dragon, I'll hand it back to you in Hawthorne for more details on the vehicles involved in this mission. Yomei?
As we continue to count down, let's take a closer look at the vehicles that will be taking CRS-31 to the space station today. Sitting atop the Falcon 9 rocket, Dragon and its trunk stand about 27 feet tall. Dragon has 16 Draco thrusters that can be used in space to help navigate the spacecraft to its destination, each providing 90 pounds of force. Dragon's trunk attached below the spacecraft holds solar cells that power Dragon while it's in free flight. and the trunk can also carry unpressurized cargo, which it will be doing today. About 50 seconds after separation, Dragon's nose cone deploy sequence will begin, exposing its guidance navigation controls that help Dragon autonomously fly to the space station. The nose cone also houses the docking mechanism that will connect with the station. Dragon has played a significant role in advancing our future in space by safely transporting crew and cargo to and from the space station. Altogether, the reusable Dragon spacecraft fleet has completed 9 human spaceflight missions on behalf of NASA and has both visited the station and returned to Earth 43 times under NASA's commercial resupply and commercial crew programs. This particular spacecraft has supported 4 previous commercial resupply missions for NASA, including CRS-21, 23, 25, and 28. And launching Dragon to orbit today is Falcon 9, a 2-stage rocket developed and manufactured by SpaceX, known for its safe, reliable, and cost-effective access to space. Just underneath Dragon, we have the second stage of the vehicle. The second stage is powered by a single Merlin vacuum engine, or MVac, which is optimized to perform in the vacuum of space. And that second stage will secure Dragon's entry into low Earth orbit before separating, leaving Dragon to continue its journey to the space station on its own thrusters. Just below the second stage is the first stage, which contains 8 engines arranged around one center engine, all held in place by a structure called the octaweb. Each of these Merlin 1D engines delivers about 190,000 pounds of thrust at sea level, which gives Falcon 9 a combined 1.7 million pounds of thrust. The booster supporting today's mission previously launched 4 missions, including Crew 8, Polaris Dawn, and 2 Starlink missions. Now, with T0 coming up in just about 12.5 minutes, our teams in Florida are doing a series of system checks to ensure Dragon and Falcon 9 are ready to fly. Now, while on station, the CRS-31 spacecraft flying today may also perform 2 initial tests to demonstrate Dragon's ability to control the space station's attitude as well as Dragon's reboost capability. Reboosts are necessary to counteract the effects of atmospheric drag, which can cause the station to lose altitude. Once the station is in a configuration for SpaceX's reboost demo, the aft Draco engines in the service section will fire for just over 12 minutes and give the station a boost. SpaceX has partnered with NASA on the creation of control algorithms to help guide and steer the Dragon and ISS through these dynamic events, which will be the first time Dragon performs tests of this nature on station. SpaceX will leverage data collected during CRS-31 to inform important analyses, which will support future enhanced capabilities and programs like the U.S. Deorbit Vehicle, or USDV. NASA selected SpaceX to develop and deliver the USDV, which will be used to deorbit the space station in a controlled manner after the end of its operational life in 2030. The USDV will be based on today's Dragon, but will feature a redesigned, larger trunk section with more Draco thrusters to help lower the station's orbit. The vehicle will also need 6 times the usable propellant and 3 to 4 times the power generation and storage of today's Dragon spacecraft. Falcon 9 and Dragon have played a significant role in advancing our future in space by safely transporting both crew and cargo to and from the space station. There are currently 3 Dragon capsules used for cargo missions, which have collectively flown 10 CRS missions to date, and there are 4 capsules supporting human spaceflight that have docked to the station. Their names are Endeavour, Resilience, Endurance, and Freedom. Crew 9 arrived on board Dragon Freedom, which is currently docked to the station and is SpaceX's 15th human space mission since 2020, when Dragon became the first private spacecraft to take humans to the International Space Station. As Joseph mentioned, Crew 9 actually just completed a port relocation maneuver from the forward port to the zenith port over the weekend to make room for CRS-31 launch today. Now, as the countdown continues, let's check back with Joseph at JSC.
Thank you very much, Yome. Teams here in Houston continue to monitor the countdown of NASA's SpaceX CRS-31 mission with everything on track for a successful launch. 2024 has been a year of important achievements for the International Space Station, showcasing what's possible through collaboration, as NASA's 31st commercial resupply mission with SpaceX marks the 12th launch to the orbiting laboratory this year. And it's clear that success in space is a collective effort, built on dedication and teamwork. Let's take a closer look at how this team effort has kept the station thriving throughout the year.
The year began with Progress 87 delivering essential supplies to the International Space Station. NASA's SpaceX 29th commercial resupply mission followed, bringing critical research and hardware, ensuring support for science aboard the orbiting laboratory. Axiom Mission 3 expanded the station's research capabilities, introducing new perspectives from around the world. In March, NASA's SpaceX Crew 8 launched from Florida, each crew's transition mirroring the importance of coordination and teamwork in maintaining station operations. As the year progressed, NASA's 30th resupply mission with SpaceX and the arrival of additional crew aboard Soyuz MS-25 sustained the flow of research, resources, and explorers. Progress 88 reinforced the station's supply chain, maintaining momentum for new scientific discoveries. As summer arrived, Boeing's Crew Flight Test marked a key milestone in human spaceflight. And Northrop Grumman's NG-21 mission delivered supplies critical to daily life and research. The arrival of Soyuz MS-26 added to the station's capability for long-duration human spaceflight. With the recent arrival of Crew 9, the station continues to be a hub of progress and global cooperation. It's a place where scientists and explorers from across our planet work together, advancing our understanding of life in space, creating opportunities for the future. Every mission this year, from cargo deliveries to crewed launches and hosting 25 residents, reminds us that space exploration is a shared endeavor. The commitment and adaptability of countless individuals, both on Earth and in orbit, keep the station thriving. As we look ahead, we remain focused on building a future where exploration continues to push boundaries for all humanity.
As we reflect on the accomplishments of 2024, it's clear that every milestone aboard the International Space Station is made possible through the dedication and teamwork of countless individuals around the world. And that journey doesn't stop there. This mission is set to deliver over 3 tons of critical cargo, including scientific hardware and samples that will advance our understanding of the physical and biological phenomena. The microgravity environment of the space station provides a unique opportunity to conduct research that can drive new technologies for deep space exploration and improve life back here on Earth. Behind every experiment, there are scientists and engineers who have spent months, sometimes years, preparing for this moment. Let's take a look at some of the science heading to the station.
NASA and its international partners are launching scientific investigations on SpaceX's 31st commercial resupply services mission to the International Space Station. The Coronal Diagnostic Experiment, or CODEX, will examine solar wind and create a global comprehensive data set to help scientists validate theories for what heats solar wind, which is 1,000,000 degrees hotter than the sun's surface. A live Antarctic moss will be studied to understand the effects of cosmic radiation and microgravity on plants. Results could help identify biological systems suitable for use in bioregenerative life support systems on future missions. Dozens of samples will be exposed to space to evaluate material stability and to help researchers better understand the impacts of spaceflight. Results could support better design for spacecraft and satellites. Researchers will demonstrate cold welding techniques in space and evaluate sample integrity. Results could aid in the development of interior spacecraft repair methods and improve applications of cold welding on Earth. Discover more about all of the science making the journey to the orbiting lab at nasa.gov/ISS-science.
It is currently T-minus 5 minutes and 10 seconds, and everything continues to be go for launch. Coming up shortly, the transporter erector, also known as the strongback, or TE, will retract away from Falcon. The TE is the large truss structure you see there.
Falcon 9 tanks are pressing for strongback retract.
Next to the rocket, you just heard that call out that the tanks are pressing in preparation
Dragon is in configure for terminal count.
for strong back retract, and Dragon is in configure for terminal count.
Dragon is in terminal count and is on internal power.
There is that call out for Dragon transitioning to internal power. And ahead of the transporter erector reclining, you'll see the clamp arms just below Dragon
Strong back lower has started.
begin to open. Now, the transporter erector is designed to transport, raise, and support Falcon 9 at the launch pad and uses its umbilicals or flexible lines to route the vehicle's fluids, power, and telemetry from ground systems to the rocket and payload until Falcon 9 switches to internal power. There you can see those clamp arms beginning to open right under Dragon at the top of the second stage. You should see that truss structure on the right.
On countdown, LD pulling for MD for final status check.
MD is go for launch.
You see the transporter erector reclining from Falcon 9. And there it is, fully reclined from Falcon 9.
Range is also green and ready to support. If for some reason we are not able to launch tonight, we do have a backup opportunity tomorrow, Tuesday, November 5th at 8:06 a.m. Central Time, 9:06 a.m. Eastern. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. At T-minus 60 seconds, Falcon 9 will be in startup. This means that the rocket's autonomous internal flight computers have taken over the launch countdown. And just inside T-minus 2 seconds, we'll light the Merlin 1D engines for liftoff.
The vehicle continues to be healthy, and the Falcon 9 team is tracking no issues. Currently, the weather is green, and the range is ready to support at T0 at 9:29 p.m. Eastern Time. Weather is looking good, and in these last few minutes, Falcon 9 is performing final health checks on the primary communications, avionics, and propulsion systems ahead of launch.
Stage 2, locks load complete.
With that, we're hearing the checkouts of the second stage thrust vector control actuators underway and referred to as the engine gibble or wiggle test. And this is when SpaceX moves the nozzles ever so slightly to make sure that the guidance hardware is acceptable for flight. And as Dragon now moves into auto idle, continues those checkouts for the first stage engines, and that happens just seconds before ignition. At the time of launch, the International Space Station will be flying some 260 statute miles crossing the Atlantic Ocean.
Falcon 9 is in startup. Dragon is in countdown. SpaceX launch director, go for launch.
There is that final launch director go. All systems are go for launch of Falcon 9 and the Sierra 31 mission.
T-minus 30 seconds. Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, engines full power, and liftoff.
Go SpaceX, go Falcon, go CRS.
Vehicles pitching downrange.
And we have liftoff. NASA's SpaceX 31st commercial resupply mission is on its way to the International Space Station, carrying science, supplies, and the spirit of exploration.
Now, during ascent, we will tilt or gimbal the engines, guiding the rocket into what we call a gravity turn. Now, during this turn, the vehicle is flying both up and horizontally away from the launch pad. The rocket
Power telemetry nominal.
typically needs to go 17,500 miles per hour horizontally in order
Falcon 9 is supersonic.
avoid getting pulled back down to Earth. You just heard that call out that Falcon 9 is supersonic. And shortly, we'll be throttling the engines back in preparation for max Q.
Max Q.
There's that call for max Q. That's the maximum aerodynamic pressure that the vehicle will see during ascent. And coming up shortly, we will have a few events in quick succession, starting with main engine cutoff, followed by stage separation,
Stage 2 engine chill.
second engine startup 1, and the boost back burn of the first stage. You just heard the call out for the second stage engine chill, starting in preparation for that engine startup. We are just about 30 seconds away from main engine cutoff, where the 9 Merlin 1D engines on the first stage will shut down. Shortly after that, the stage 1 and 2 will separate from one another, and the MVAC engine on the second stage will start. Second engine start 1 is when we ignite that single Merlin vacuum engine of the second stage. Shortly after that, the boost back burn will start on the first stage. There's main engine cutoff.
Main engine cutoff. Stage separation confirmed.
Stage separation.
Stage 2 startup. Stage 1 boost back startup.
And there you can see a beautiful view of the concurrent second stage engine start, along with the start of that first stage boost back burn. And really cool views from the second stage engine there and the first stage. Now, if you're just joining us, the first stage on your left is in the middle of its boost back burn, which is the first of 3 burns designed to take the first stage back down to Earth to our landing zone 1. And the second stage is in its burn, carrying Dragon and the CRS-31 mission towards its intended orbit.
Stage 1 boost back shutdown.
There is the end of that boost back burn. Again, that was the first of 3 planned burns of the first stage. And in about 3 minutes, there will be 2 additional burns, the entry burn and the landing burn of that first stage, to bring it back down to land at landing zone 1 at Cape Canaveral. We are at T plus 3 minutes and 55 seconds here in today's mission. CRS-31 is SpaceX's 105th launch this year, and we are coming up on the entry burn and then second engine cutoff of the second stage. Now, the entry burn is slated for a little over 2 minutes from now at the T plus 6.5 minute mark, and you should see that on your screen when the first stage performs it. And for that entry burn, we relight 3 of the 9 M1D.
Vehicles are on a nominal trajectory.
You heard that call out. Vehicles are all on a nominal trajectory. And again, for that entry burn, we will relight 3 of the 9 M1D engines, starting with the center E9 engines, followed shortly after by the E1 and E5 engines, which are on either side of it. And this burn will slow the vehicle down as it passes back into the Earth's atmosphere. Now, the reason we need to perform this entry burn is we need to slow down to reduce re-entry forces, which helps us to recover and reuse the first stage. You can follow along on the bottom left and right hand of your screen for the speed and altitude for the first and second stages, respectively. And the second stage, which you can see on your screen right now, is on its first burn. And this is what will be targeting the Dragon orbit, from whence, after Dragon's operation, Dragon will continue the rest of its journey to the International Space Station using its own onboard Draco thrusters. We are just about 30 seconds from the start of the first stage entry burn. This will be about a 20-second burn that slows that first stage down as it re-enters the Earth's atmosphere.
Nominal trajectory.
We are also currently in the middle of the second stage burn. We have about 2 minutes left in this burn.
Stage 1 entry burn.
There is the start of the stage 1 entry burn, and this is a 3-engine burn of the first stage, slowing the first stage down as it comes back home to
Stage 1
Earth.
entry burn shutdown.
Stage 1 FTS is saved.
And there is that call out for a good entry burn and the flight termination system being saved. Really cool views of the nighttime on the Cape Canaveral coast. At the first stage that supporting today's mission will perform, has performed this entry burn for the 5th time. And Falcon 9 is the world's first orbital class reusable rocket. And this is important because it allows us to reuse the most expensive parts of the rocket, which drives down the access to space. We should see that landing burn starting in just a few moments.
Stage 1 landing burn.
There is the start of the stage 1 landing burn.
Stage 1 landing leg deploy. Stage 1 landing is confirmed.
What a beautiful view of that
terminal guidance.
first stage landing. And with that landing marks SpaceX's 360-second recovery of an orbital class rocket, including the first stage landings for Falcon 9 and Heavy. And we are coming up on second engine cutoff 1 here on the second stage in just a few moments.
Stage 2 shutdown.
There is that call out for SECO 1. You can see that MVAC engine slowly cooling off.
Nominal orb insertion.
There is that confirmation of a good orbit. Looks like we are on track for Dragon separation in just a few minutes here at the T plus 9 minute and 25
Stage 2 FTS is saved.
second mark. You can see that MVAC engine continuing to cool down. And we are waiting for Dragon separation here in just a few moments.
Dragon separation confirmed.
There is confirmation of Dragon separation. You could just see it floating away there. Now, if you're just joining us, we did have a successful launch from Launch Complex 39A at Kennedy Space Center. and everything has proceeded nominally so far. We had stage separation occurred at about 2.5 minutes into flight, and that was followed by a successful landing of Falcon 9's first stage on landing zone 1, and that marked the 5th landing for this particular booster. And for those of you following along, this Dragon spacecraft previously supported 4 commercial resupply missions for NASA, including CRS 21, 23, 25, and 28. At about a few minutes ago, we had a successful second engine cutoff, or SECO-1, and this was followed by a confirmation of a good orbital insertion. We recently saw Dragon separation floating away from the second stage as it begins its journey to the International Space Station. We should see the start of nose cone deploy here for Dragon shortly as well. A very exciting sight to see. Dragon, you saw, was drifting away from Falcon 9's second stage, confirming spacecraft separation. Let's check in with Joseph as we prepare for nose cone deploy and preview what's in store for the rest of the flight.
Thank you very much, Yome, and we're following along here from Mission Control in Houston. A wonderful launch of Dragon from the historic launch pad 39A at NASA's Kennedy Space Center in Florida, and it's great to see Dragon in orbit and starting its journey on the way to the International Space Station. We're continuing our coverage here in Mission Control Houston and awaiting for the nose cone to deploy, and that is currently about to begin here in just a few moments. The nose cone is at the very tip of the Dragon spacecraft, and once it's deployed, it will expose the 4 forward bulkhead Dracos. These Draco thrusters will execute a series of maneuvers necessary to raise Dragon's orbit and meet up with the International Space Station, and all that will begin in a little over half an hour from now. Now, for Dragon overall, it is carrying well over 3 tons of cargo that is heading to the International Space Station and the Expedition 71 crew, and that includes crew supplies, of course, science investigations, spacewalk equipment, vehicle hardware, and computer resources. And one thing that the Dragon is carrying also is a lot of food for the crew on board. And a common and fun question we get here at NASA is what kinds of delectables are inside Dragon and are on their way to the station for that crew who are anxiously awaiting them. And we did receive note that there is a fresh food kit that includes some fruits and vegetables, much like citrus and apples, some blueberries, sweet onions, and all that on its way inside Dragon right now. There are also 4 zipper crew kits, including crew preferences of coffee. With the holidays arriving, there's 1 bulk overwrap bag, or bob, that features special occasion holiday items like lobster, crab, and quail. In addition to these items, there are also 110, that's right, 110 bulk overwrap bags containing standard food menu items, as well as some crew preference choices along the way. Now, as we take a look at the control rooms that are monitoring Dragon's progress and the International Space Station, there on your left, the International Space Station Flight Control Room, which is where we are here in Mission Control Houston. And then, of course, on the right, the teams in SpaceX monitoring Dragon's journey. And now this journey is going to continue on into the early morning hours and through the phasing burns that will be required to get Dragon to the space station by both teams, and then they'll come together jointly just before docking to work and connect the cargo craft to the orbiting laboratory. And we're continuing to await the nose cone deploy of the Dragon craft as we continue to monitor everything here from Mission Control Houston. Now, we mentioned a series of burns required for the spacecraft once it reaches orbit, which it just did. And now in about 30 minutes or so, we will see that first round of what will be 5 burns that will take Dragon onto its next phase of the mission. So as we continue to await the confirmation of nose cone deploy, let's take a closer look at the next several hours and what's in store for the Dragon spacecraft. Now, immediately after Dragon separated from the Falcon 9, it begins what we call the activation and rendezvous phase of the mission. And during this phase, Dragon is configured for on-orbit operations. And this phase begins after the separation of Dragon from Falcon 9 and ends with the completion of the final co-elliptic burn. Our initial orbit today is 190 kilometers by 210 kilometers. and with those values representing the perigee and apogee of the orbit, or the lowest and highest points over Earth. That means the orbit isn't a perfect circle, but more like a very slight ellipse. Now, over the next several hours after liftoff, Dragon will execute a series of burns, which will gradually raise its orbit to align more closely with the station. And there are 5 major burns, or firings, of those Draco thrusters on Dragon that will bring the spacecraft close to station before we begin those final approach maneuvers. As we take a look inside the nose cone of Dragon as we speak, as the nose cap is opening right in front of us, and continuing to watch the nose cone deploy, again exposing those forward bulkhead thrusters that will begin those 5 phasing burns for the spacecraft, and we will get video back as soon as possible. But to quickly take a look at some of those burns as the nose cone approaching the about halfway point of opening. The first burn is the phase burn, and that's the first major one that's going to come in about 33 minutes from now, and that's performed at the apogee, or the highest point of the initial orbit, and will raise Dragon's perigee, or lowest point, to a higher altitude. And then from there, we'll transfer over to the boost burn, which will happen in the early morning hours. The next burn, based on what our orbital data will show us, is that'll raise Dragon's orbit until its orbit reaches an altitude that is just 10 kilometers lower than the space station. And from there, we'll move into burn number 3, the close coelliptic burn. And that's followed soon by to place Dragon on an orbit roughly coelliptic with the International Space Station. And this means that the crew will be about 10 kilometers lower than the space station itself during the entire orbit around the Earth. And then we move into burn number 4, which will be the transfer burn. And this is called the transfer burn, where we will be raising Dragon's apogee, or again, the highest point of its orbit, to just 2.5 kilometers below the station. As we continue to monitor the nose cone deploy of Dragon as we speak, about 3/4 of the way there to transfer us into the burn breakdown of the 5th burn, the final coelliptic burn. And that is where we will round out everything with that final coelliptic burn to once again maintain a constant orbit beneath the station, this time just 2.5 kilometers below. And then from there, Dragon will get ready to line itself up, fine-tuning its way before docking in the early morning hours of tomorrow. And that'll start with the approach initiation and then make its way on to waypoint 0. As we continue coverage in a successful on-time launch of NASA's SpaceX 31st Commercial Resupply Services mission en route to the International Space Station. As nose cone deploy just a moment away from locking into position. And we just received confirmation that the nose cone has indeed been deployed, exposing those Draco thrusters that will help the spacecraft climb its way and begin its journey en route to the International Space Station. Now that the nose cone is deployed, Dragon is ready for its phasing burns to the International Space Station with a successful orbital insertion. And I'm now joined by Bill Spetch, Operations Integration Manager of the International Space Station. Bill, thank you very much for joining us.
Great to be here.
We've discussed the crucial role of collaboration, teamwork, and dedication in making missions like this possible and ensuring a continuous flow of science, technology, and resources. How have you witnessed this in your team's preparation for this mission and in recent missions?
Well, you know, operating a world-class orbiting laboratory requires extensive collaboration across all aspects of the ISS program. We have adapted to numerous items that were not as we originally planned, and we have the best team in the world, and really around the world, working solutions to every potential problem that could arise. Most recently, the outstanding international collaboration around the very busy traffic schedule to ISS, and adjusting to that ever-changing launch and landing schedule while we prepared for the future by adding new capabilities to the ISS.
It certainly has been a busy time for the space station. It feels like it's been like that for quite some time now. And with this cargo mission, add that to the traffic dossier for this mission. Well, in addition to the cargo being delivered aboard it, another important aspect of this mission is showcasing the spacecraft's reboost capabilities. We touched upon it earlier in the broadcast of this importance and what it means to the International Space Station. But can you explain the significance of this ability and its importance for the space station?
Yeah, the ISS requires periodic boosts to maintain its orbit around the Earth. And normally these are completed by Progress, the Zvezda service module, or even Cygnus. It is important to us to continue to add capability to the ISS, and performing reboost with Dragon is an awesome addition to that capability. Plus, this allows the team to gather data that helps inform the design and operation eventually of the US-2 orbit vehicle.
In your time and in your career with the International Space Station, you focused on maintaining its health and its integrity. How do missions like this one help achieve those goals while also advancing the station's capabilities, like you just touched upon with some of the traffic coming to and fro, also the scientific research and the technological developments?
You know, ISS depends on a steady flow of supplies to safely maintain and continue on with its mission. This mission delivers examples of all those needs for the vehicle. Dragon will deliver food, spares, and of course the very important science that we conduct on board. Dragon also returns items to the ground. This allows us to refurbish hardware instead of building new copies, investigate designs and improve reliability for future spaceflight endeavors, and allows the scientific sample return to Earth that furthers research.
Well, we look forward to seeing all that this mission has to have in store, especially those reboost capabilities for this Dragon spacecraft. Bill Spetch, Operations Integration Manager of the International Space Station. Sir, thank you very much for your time.
Thank you.
Dragon now begins its journey towards the International Space Station, using phasing burns to gradually close in the distance. This process will take about a day and a half, with approach and docking expected actually early tomorrow morning at 9:15 a.m. Central Time, 10:15 a.m. Eastern. Tune in to NASA Plus for live coverage of the final approach and docking starting at 7:45 a.m. Central Time, 8:45 a.m. Eastern, with docking expected around 9:15 a.m. Central, 10:15 a.m. Eastern. With a couple of hours after docking and settling in, the Expedition 72 crew will perform a series of leak checks, and the crew will begin to then unload the Dragon spacecraft. For the latest updates, be sure to visit nasa.gov. We will see you tomorrow for docking, and until then, let's check in one more time with Yome and our team in Hawthorne. This is Mission Control Houston.
Thanks, Joseph. The Dragon supporting CRS-31 will return to Earth in about 1 month. SpaceX is honored to be a part of NASA's Commercial Resupply Services initiative to deliver critical cargo to the space station, and we thank NASA for entrusting us with today's mission. This mission marks our 105th of the year and our 400th successful liftoff of Falcon. Thank you to the entire SpaceX team and to all of our customers for helping to make this incredible journey possible, and congratulations to the SpaceX and NASA teams for tonight's successful launch. Make sure to follow at SpaceX on X and check out spacex.com/launches for up-to-date missions and schedules. Thanks as always for tuning in, and have a good night.